Welcome to the AI and GIS Frontier podcast. Let's get into today's topic.
For our final episode in this series, we are looking at Next Gen GeoAI Research directions. The academic community is actively defining where this field goes next, and these research agendas will shape the tools GIS professionals use in 3 to 5 years.
What are the big research themes emerging?
The journal article towards the next generation of geospatial artificial intelligence laid out several key directions. Knowledge-guided GeoAI, which means building domain knowledge like ecological principles or hydrological rules directly into AI models, rather than learning everything from data alone. Spatial representation learning, developing better ways for AI to understand spatial relationships, proximity, connectivity, and scale. Fairness-aware GeoAI, ensuring models work equitably across different geographies and communities. And privacy-preserving GeoAI, enabling spatial analysis without exposing sensitive location data.
Knowledge-guided GeoAI sounds particularly relevant for forestry and environmental work.
It is, and here is why. Current AI models learn patterns from data, but do not understand ecological principles. A purely data-driven model might predict that a clear-cut will regenerate in 5 years, because that is what the training data shows, without understanding that soil type, aspect, and elevation affect regeneration rates. Knowledge-guided GeoAI would embed those ecological relationships into the model architecture. The result is models that make physically plausible predictions, even in situations not well represented in the training data. For forestry, this means growth and yield predictions that respect known silvicultural relationships, and environmental models that obey conservation laws and ecological constraints.
Open-source LLMs are being explored as alternatives to commercial models for GIS.
This is a significant research direction. A paper in the Annals of GIS examined how open-source large language models can shape the future of GeoAI. The argument is that relying on commercial APIs from OpenAI or Google for geospatial analysis creates dependency, cost, and data privacy risks. Open-source alternatives like Llama and Mistral can be fine-tuned for geospatial tasks and run locally. For a government forestry agency that cannot send sensitive land management data to a cloud API, this is critical. The research shows that specialized open-source models can match or exceed commercial model performance on geospatial tasks when properly fine-tuned.
There is a comprehensive survey on LLM-powered spatial intelligence across multiple domains.
Yes, researchers surveyed how LLMs are being applied across embodied agents, which are robots and autonomous systems that navigate physical space, smart cities, and earth science. The common thread is spatial reasoning. How well can an AI model understand that object A is north of object B, that a river flows downhill, that a forest fire spreads based on wind direction and fuel type? Current LLMs have surprising spatial reasoning capabilities, but also significant blind spots. The research is pushing toward models that have native spatial understanding, rather than treating location as just another text attribute. For GIS professionals, this means future AI assistants will be much better at understanding the spatial context of your analysis requests.
The GeoAI with Python textbook represents a shift toward education and accessibility.
The fact that there is now a free, comprehensive textbook on geospatial AI tells you the field has matured past the early research phase. It covers everything from data acquisition to model deployment in a format accessible to GIS professionals, not just computer scientists. The FOSS4G 2025 reinforced this trend, with sessions focused on practical deployment patterns, not just novel algorithms. The message from the research community is clear. Geospatial AI is ready for widespread adoption, and the educational infrastructure to support that adoption is being built.
What should GIS professionals watch for in the next year?
5 things to track. First, the continued development of geospatial foundation models, especially multimodal models that can handle satellite imagery, vector data, and text simultaneously. Second, the maturation of autonomous GIS agents from research prototypes to usable tools. Third, the growth of the open-source stack, TorchGeo, TerraTorch, and GeoAI, as alternatives to proprietary platforms. Fourth, the evolution of geospatial AI governance, especially around satellite surveillance and geo-privacy. And fifth, the integration of AI into every major GIS platform, making these capabilities available without specialized programming skills. The overall trajectory is clear. Geospatial AI is moving from specialist research tool to everyday professional capability.
What a great way to wrap up this series. The future of GIS is deeply intertwined with AI, and the opportunities for professionals who embrace this are enormous.
They really are. The research agenda points toward a future where AI amplifies the capabilities of every GIS professional, making spatial analysis faster, more accessible, and more powerful. The professionals who invest in learning these tools now are going to lead the field for the next decade. Thanks for following along with this series, and keep pushing the boundaries of what is possible with geospatial AI.